Okay, so today our job is to find out the shear force and bending moment diagram for a simply supported beam. So this AB is a simply supported beam which have the uniformly distributed load at the rate 4 kN per meter, and at point D there is a couple having 10 kN meter value. It is clockwise, and at E there is an inclined load 8 kN at a angle of 30 degree with horizontal, and at B there is a roller support. So today in this example we will learn different things. Firstly, shear force and bending moment diagram for a simply supported beam. Secondly, for uniformly distributed load. Thirdly, when there is a couple, and fourth, when there is a inclined load. So we need to draw a few lines like this from each point, and these horizontal lines will be representing the shear force and bending moment, and these lines will be the ground lines or reference lines, okay, or base lines. Now this line represents 0. Now we need to replace the supports by the reaction forces. So there is a reaction force which will be called RA, and this will be called RB. These are vertical reaction forces. Now we will convert this 8 kN load into two perpendicular components. Firstly, for 8 kN load there is a vertical component which will be 8 sin 30, that means 4 kN, and 8 cos 30, which will be 6.93 kN, working at point E. So along the force it has components in leftward direction 6.93 kN and having 4 kN vertically downward at point E. Now if we look at this beam, at B there is a roller support, so this roller support cannot support this horizontal load, so that's why this horizontal load 6.93 kN is totally getting supported by the reaction created at fixed support A. So at fixed support A there is a reaction force which is vertically upward, as well as there is a vertically horizontal force which will be equal to 6.93 kN. To support this load there is a reaction will be created at A which will be horizontal. So RA horizontal will be equal to 6.93 kN, which will be the horizontal load at point E. This is resisting this. Okay, so horizontal loads, horizontal reactions are found out which are not relevant for shear force and bending moment diagram. So we will just keep them at it is. Now we will work with the vertical loads only. So first of all we need to find out this RA vertical and RB. Okay, to find out RB we need to take moment about A. So if we take moment about B, then what we will get? We will get RA. So if we take moments about B, then what we will find? Moment about B. Moment about B will be RA into 10, which will be clockwise. And sorry. Okay. So we were taking moment about B. So clockwise moment should be equal to the anticlockwise moment for the case of equilibrium. So the clockwise moments are RA into 10. 10 is the distance of A from B, and another clockwise moment is 10, that is a couple which is working at B. This is the total clockwise moment, that will be equal to anticlockwise moment 4 into 3, because of this uniformly distributed load. 4 into this distance is 3, this is 3 meter, this is 2 meter, this is again 3 meter, this is again 2 meter. So distance 3 plus 2 5 plus 3 8 plus 2 is 10, and this couple is 10 kilonewton meter, so it is placed directly. Okay, now this is RA into 10 plus this is 10, this one is equal to 4 into 3, 12 kilonewton, and it is working from here, so it will be working at 10 minus 1.5, that will be 8.5 counterclockwise. So plus there is another for 4 kilonewton load, so 4 into 2. Okay, so RA will be equal to 12 into 8.5 plus 8 minus 10 divided by 10. Okay, so let us calculate. So RA is, by calculation, RA is 10 kilonewton. Okay, now then of course RB is equal to total downward loads, 4 into 3 plus 4 minus upward load 10, so this will be 6 kilonewton. Okay, now RA and RB are known, then we go for the diagram. Okay, then for portion AC, the distance measured MEA SURED, measured from A. Now section XX taken between A to C, then the shear force becomes, because of the force RA, the shear force will be positive, and because of the uniformly distributed load, the shear force will reduce along with the increase of X. So for portion AC, if any section at XX at a distance X from A, Fx will be equal to 10 minus 4 into X. So Fa will be equal to 10 and Fc will be equal to 3 minus 2. Okay, so at C shear force minus 2 kilonewton, at A shear force 10 kilonewton. Okay, so that means shear force becomes 0 where F minus 4 is equal to 0. So X equal to 10 by 4 is equal to 2.5 meters. So at X equal to 2.5 meter, it becomes 0. So let us draw. Suppose this is 10. So from here, this much is plus 10 kilonewton and this much is minus 2, and from here to here it is 2.5. So at distance 2.5 meter, the shear force is 0, and at A it is 10 kilonewton, at point C it is minus 2 kilonewton. Okay, these are all kilonewton and this is in meter. Okay, so now there is no load up to E, there is no load from C to up to E. So from here up to E, the shear force remains minus 2 kilonewton, and then there is a 4 kilonewton load. So again it is a downward, so it is trying to move the leftward section, it's trying to move the leftward section downward. So if left section downward, that means it will be negative shear force. Just we have learned before. So again from -2 to, again it will be reduced by 4 more kilonewton. So it will be like this, and from E to B it will be like this. So this much is -4 kilonewton from here to here. So this much is actually -6 kilonewton. Okay, now all the relations will be linear here. Okay, I hope you understand. So this will be the shear force diagram. Now we will go for the bending moment calculation. For bending moment calculation for portion AC, for portion AC, okay. If we take section XX at a distance x from A, then mx will be equal to 10 into x minus 4 into x square by 2, and this beam is under sagging action, so the bending moments will be positive here. So this is the equation where 4x is the load and x by 2 is the distance from A. Now if it is so, the relation is parabolic, and for MA x equal to 0, so it becomes 0, and at MC x equal to 3, so it will become 10 into 3 plus 4 into 9 by 2, so 30, sorry, this will be minus, so this will be 12 kilonewton. So from A to C, this will be parabolic. We have to write that this curve is parabolic, and this value here is 12 kilonewton plus. Okay, now if we want to know the maximum bending moment, then how can you find it out? Bending moment is maximum where the shear force changes sign. The shear force changes sign, that means shear force is 0. At that particular point, the bending moment maximum. So from A to C, shear force changes sign at x equal to 2.5 meter. So if that point is represented by, say, some other point F, then at 2.5 meter the bending moment, so this is F, this is C, this is D, this is E, this is C, sorry, this is C, this will be C dash, D, E. Okay, now we have to find the value F dash. So MF is x equal to 2.5 minus 4 into 2.5 square by 2, and that will become, upon calculation, is 12.5 kilonewton meter. Okay, so between A to C the maximum bending moment is 12.5 kilonewton meter. This is not necessary. If it is asked, then you can write. Okay. Okay. Now our next target is to find out the bending moment at D. So for the portion CD, if a section XX is taken at a distance x from A, then it will be 10x minus 12 into x minus 1.5. 12 means 4 into 3. Now this equation is of course linear. So MC on calculation is 12 kilonewton, just like before we have found out kilonewton meter, sorry. So it will be continuous, and M at D will become at x equal to 5, 8 kilonewton meter upon calculation. So this will be reducing at a linear rate. So this will be D dash, and here D dash will be equal to 8 kilonewton meter. So this will be 8 kilonewton meter. 8 kilonewton meter. Okay. Now C to D, it's linear. Let us write it's linear curve from C to D. So from C dash to D dash, it is linear. Okay. Now we have made C to D. Now we will go for D to E. Okay. From portion D to E. So from portion D to E, if a section XX is taken at a distance of x from A, then mx will be equal to 10x minus 12 into x minus 1.5 plus 10. Because of this 10 over here, this value is 10 kilonewton meter. Here this was 10 kilonewton meter, so that 10 will be added over here. Okay, if you look at it, it is a linear equation, so again it will be changed as linear. So MD, that means at x equal to 5 we will get as 18 kilonewton, which is, before we have found 8, now we are finding 18. Because of this 10, the value rises by 10. So D double dash, so D double dash is 10 kilonewton meter. Okay, so D dash, D double dash 10 kilonewton meter, and D double dash is 10 plus 8, 18 kilonewton meter. Okay, now for the portion E to B, for the portion E to B, if a section is taken XX at a distance x from A, then mx will be equal to 10x minus 12 into x minus 1.5 plus 10 minus 4 into x minus 8. So in such case, ME at x equal to 8 will be found out 12 kilonewton meter. We will put ME x equal to 8. Location of E from A at a distance of 8 meters. So we put x equal to 8 and we will get ME is 12 kilonewton meter. Okay. So ME, it will decrease at a linear way. So EE dash is 12 kilonewton meter, and the change here we find is linear. So this will be linear. Now at a distance 10 we will find MB x equal to 10. We will get the value is 0, because on the supports most of the cases we get bending moment 0 in case of simply supported beam. So from E to B the equation is linear. So from here to here it goes 0, and this is also linear. So this is what we will get. This will be the area under the bending moment diagram. Okay, so please go through, so that you must make sure that you are able to understand. If you find any problem, please contact me. Thank you.